Hello everyone, in this video we're going to learn how to solve trigonometric equation, sine, cosine, and tangent. Alright, first we're going to talk about the sine function. Sine s equals m. You know that the sine function has the period of 2 pi, right? Domain should be all real numbers, right? And the range should be -1 to 1. Keep that in mind. Now, sine s equals m. If m is outside the range, the equation has no solution. For example, if I ask you to solve sine of angle theta equals phi, this equation has no solution, right? Because phi is outside -1 and 1, right? Another equation like sine theta equals -2, right? -2 is less than -1, right? So this guy is outside the range. So this equation has no solution. Now, in order for this equation has solution, m must be in the range -1 to 1, right? So sine s equals m, and then when you take inverse, it should be s equals sine inverse of m plus k 2 pi. And the second solution, pi minus sine inverse of m plus k 2 pi, right? So because the period of the function sine s equals 2 pi, you just keep adding multiple of 2 pi's to get the same values as the original values, right? Now you have the special case, sine of s, which means the y-axis, right? And cosine of s, which means the s-axis, right? Now sine of s equals 0 when s equals 0 and s equals pi right here, right? Because right at this value, you're gonna project out to the y-axis, and you see that 0 value right here, right? This guy project out to the y-axis, you get 0 right here, right? So basically, the y value right here equals 0, right? You keep repeating every single pi, and you get another 0 right here, right? And you keep repeating every single pi, you get another 0 right here, right? So basically, s equals k pi, right? If k equals 0, I get this guy right here. If k equals 1, I get this guy right here. If k equals 2, I get this one. Now, the second special case, if sine s equals 1, right? So 1 right here, right? Which means s equals pi over 2 right here, right? Plus k 2 pi, right? Because you need to repeat 1 full period to go back to original 1, right? Now sine s equals -1, which means this guy right here, right? So the point's right here. It's gonna be 3 pi over 2 plus k 2 pi, right? So you have s equals 3 pi over 2 plus k 2 pi, right? Or you can write s equals -pi over 2 plus k 2 pi if you go clockwise direction, right? Now cosine function is going to be similar to the sine function, right? You still have the period 2 pi, domain all real numbers, the range should be -1 to 1, right? Now if m is outside the range, -1 to 1, the equation has no solution. If m inside the range -1 to 1, and then solution should be s equals cosine inverse of m plus k 2 pi, and the second one, negative cosine inverse of m plus k 2 pi, right? Now the special case, when cosine s equals 0, right? Cosine, you look at the x-axis only, right? The angle that makes cosine equal to 0 is pi over 2 and 3 pi over 2 right here, right? Now, if I take pi over 2, I project out to the x-axis, it could be 0, right? So, the angle is pi over 2. and then 3 pi over 2 right here, which means pi over 2 plus pi, right? So every single time you keep adding pi, right? You get this guy right here, and you keep adding pi, you get another one right here, and right here, right? So it's going to be pi over 2 plus k pi. Now cosine s equals 1. You look at the s value right here, cosine s equals 1 when s equals to k 2 pi, right? If k equals 0, and then s equals 0 times 2 pi, it's going to be 0, right? K equals 1, and then s equals 1 times 2 pi, it's going to be 2 pi, right? So it's still right here. Every single time you change the value of k, it's still right here, right? Now, next one, cosine s equals -1. It's gonna be right here, right? The value of -1 right here when s was pi, right? So you have s equals pi plus k 2 pi, right? Now the tangent s equals m. The period of the tangent function is pi, right? Now the domain is all real numbers except the vertical asymptotes, right? The vertical asymptote of the tangent function is given by the formula s equals pi over 2 plus k 2 pi, right? So basically you need to eliminate the vertical asymptotes, right? Now the ranges are real numbers, right? Now the tangent s equals m, and then s equals tangent inverse of m plus k pi, because the period is pi only, right? Now let's take a look at the first example. Find all solution to the equation cosine s equals -√2 over 2, right? Now we talk about the cosine function, which means we look at the s-axis, right? And we look for the s value of the coordinate points right here, right? Now the s value that equals -√2 over 2 is right here, right? And right here, right? Now the cosine of s equals -√2 over 2, which means the angle is going to be 3 pi over 4 and 5 pi over 4 right here, right? Now, because they ask you to find all solution, which means there is no restricted domain, right? You need to write the general solution, right? So the general solution should be s equals 3 pi over 4 plus k times 2 pi, right? The second one, s equals 5 pi over 4 plus k times 2 pi, right? Because this is the first 3 pi over 4, right? After one full cycle, it's go back to over here, right? Which means 3 pi over 4, you're gonna add 2 pi. So it turns out to be 3 pi over 4 plus 8 pi over 4, and it's going to be 11 pi over 4, right? So after one full cycle, this angle becomes 11 pi over 4, right? This guy is 17. 5 pi over 4, if you add 2 pi, it's going to be 5 pi over 4 plus 8 pi over 4, and it's going to be 13 pi over 4. Right after one full cycle, this guy becomes 13 pi over 4. Alright, now let's look at the second example. Find all solution to the equation sine s equals -1, right? So we look at the formula right here. This is the special case, right? Now, since this is sine function, you look for the y value of the coordinate points right here, right? The y value that equals -1, which is this one right here, right? So you either write s equals 3 pi over 2 plus k 2 pi, right? Or you can write like this: s equals pi over 2 plus k 2 pi, right? This one you go counterclockwise. This one you go clockwise, right? For the first example right here, it should be n, right? This guy and this guy, right? Example number 2, this guy or this guy. So either way works. Now example number 3, find our solution to the equation tangent s equals 1 over root 3, right? You just radicalize this one. It's going to be root 3 over 3, right? Now, you know that tangent s equals sine s over cosine s, right? Which is y over s, right? So you look for the order pair that y divided by s equals root 3 over 3, right? So it's actually pi over 6 right here. And this guy right here. Make tangent s equals 1 over root 3, right? So you just write s equals pi over 6 plus k pi, right? Because the tangent function has the period pi, right? So it should be like this, right? So plus k pi. Now, the second one, s equals 7 pi over 6 plus k pi. This guy and this guy actually the same, right? You don't need to write both, you just write one of them, right? Because if I let k equal to 1 and it's go over here, it should be 7 pi over 6, right? So you don't need to write this one, right? This one is enough. Now let's take a look at example number 4. What are all values of theta where 6 sine theta equals 3 root 2, right? So you need to solve for sine theta first, right? You need to divide both sides by 6, right? And then you have sine theta equals root 2 over 2, right? Now you look for the y values of the coordinate points right here where y equals root 2 over 2, right? So I have this guy right here, right? So the angle should be pi over 4. And this guy right here, the angle should be 3 pi over 4, right? So I have s equals pi over 4 plus k 2 pi, right? Because this is a sine function, the period is 2 pi, right? The second one s equals 3 pi over 4 plus k 2 pi, right? This guy and this guy are different, so you cannot combine them, right? So you both have both right here. Now let's take a look at example number 5, right? So I draw number 5 over here. Let the function f of s equals 3 plus 2 cosine s and the function g of s equals 2. Alright. In the xy plane, what are the s coordinates of the points of the intersection of the graph of f and g's for theta from 0 to 2 pi, right? So this is a restricted domain, right? So you no longer write something like this, right? You need to have specific values of the angle theta, right? So in order for this guy and this guy intersect, right, you need to let this guy and this guy equals, right? So you need to write 3 plus 2 cosine of s equals 2. And you solve for s, right? So I have 2 cosine s equals negative 1, right? Because I subtract 3 both sides. And then I divide both sides by 2. So I have cosine of s equals negative 1/2, right? Now I look at the unit circle and I need to find the s value equals negative 1/2, right? So it should be right here. And right here, right? So s should be 2 pi over 3. And s equals 4 pi over 3. These two guys right here are in the domain 0 to 2 pi, right? Which means within the unit circle right here. Now let's take a look at example number 6. The function g is given by g of s equals 3 minus 4 sine square of s. What are the zeros of g on the interval 0 to 2 pi, right? Now, keep in mind, when you write sine square of s, you need to write like this, or you're gonna write like this, sine s all together square, right? But this guy right here different from sine s square, right? So don't write like this one wrong. So keep that in mind. Alright, now because the question asks you to find the zero of g, right? So which means you let 3 minus 4 sine square of s equal to 0, right? And then I'm going to subtract 3 both sides, so I have negative 4 sine square of s equals negative 3, right? Divide both sides by negative 4, so sine square of s equals 3 over 4, right? Now take square root both sides, so sine s equals plus and minus root 3 over 2, right? Now I just look at the unit circle and find the y value on the coordinate points. That equals root 3 over 2 and negative root 3 over 2, right? So root 3 over 2 is going to be right here. So you have the angle pi over 3 right here. So it should be 2 pi over 3, right? Right here, negative root 3 over 2, right? So it should be 4 pi over 3. Negative root 3 over 2 right here should be 5 pi over 3, right? So you have 4 values, right? S equals pi over 3 right here. 2 pi over 3. 4 pi over 3. 5 pi over 3. And that's it, right? Because you have to restrict the domain 0 to 2 pi, right? Now, let's take a look at the number 7. What are all values of angle theta? For theta from 0 to 2 pi, such that cosine square of theta equals negative cosine theta. So you need to copy it over here. Cosine square theta equals negative cosine theta. Now, one of the common mistakes students usually make is they're going to divide both sides by cosine theta. Alright, so this one is equal cosine theta. This one equal negative 1. If you do this way, you miss some solution. So be careful, alright? Don't do this way, this one wrong. So how do you do it? You need to add cosine theta both sides, right? So I have cosine square of theta plus cosine theta equals 0. And I factor cosine theta out. It's going to be cosine theta plus 1 equal to 0, right? So I have cosine theta equals 0 and cosine theta plus 1 equals 0, right? Now cosine theta plus 1 equals 0 is the same thing as cosine theta equals negative 1, right? Now you look at the unit circle and look for the x-coordinate that equals 0, right? So it's going to be right here. The angle must be pi over 2, right? And it's going to be right here. So the angle must be 3 pi over 2, right? So right here you have theta equals pi over 2 and 3 pi over 2. Now cosine theta equals negative 1, right? So it's going to be right here. Right? So angle should be pi, right? So this theta equals pi, right? Finally, you have three solutions. S equals pi over 2, pi and 3 pi over 2, right? Now let's look at example number 8. We need to find the x-coordinates of the points of intersection of the graph of f and g square theta from 0 to 2 pi, right? Now in order to find intersection between f of s and g of s, we need to write f of s equals g of s, right? So you just substitute 2 sine square of s for f of s equals square root of 3 sine s for g of s, right? Now again, don't divide sine s both sides, right? You need to subtract root 3 sine s both sides, right? So now you're gonna factor sine s out. So we have sine s times 2 sine s minus root 3 equals 0, right? So this is a 0 product. You just let each of this guy equal to 0, right? So you have sine s equals 0 and 2 sine s minus root 3 equals 0, right? So then we have sine s equals 0 and sine s equals root 3 over 2, right? Now I look at the unit circle, so I have the first one right here, root 3 over 2, root 3 over 2, 0, right? So the measure angle should be 0, pi over 3, 2 pi over 3, and pi, right? So s equals all of this guy right here are inside the domain right here, right? Now let's look at example number 9. Find all solution to the equation sine of 3s plus pi over 4 equals root 3 over 2. Alright, so we look at the unit circle, and because this is a sine function, right? So you look for the y values that equals root 3 over 2, right? So it could be right here, and it could be right here. So you have two values right here, right? Pi over 3 or 2 pi over 3, right? So you have sine of 3s plus pi over 4 equals sine of pi over 3, right? And the second one, sine of 3s plus pi over 4 equals sine of 2 pi over 3, right? Or you can use this formula right here. You just take pi, you subtract pi over 3, right? Pi subtract pi over 3, and this is actually 2 pi over 3, right? So you just equate this guy right here. This guy equal this guy. This guy equal this guy. So we have a system of two equations, right? The first one, 3s plus pi over 4 equals pi over 3. Don't forget to add k 2 pi, right? The formula right here. The second one, 3s plus pi over 4 equals 2 pi over 3 plus k 2 pi, right? Now, you can simplify this one. Just subtract pi over 4 both sides, right? So I have, now you just divide both sides by 3. So you have over 3, right? So these are solution to the equation, right? Remember, case is the integer, right? Now let's look at example number 10. Find all solution to the equation sine s equals 1 over 4, right? Now we're gonna check this one. This one actually in the range right here, -1 to 1, right? So we can solve it. Now we look at the unit circle right here. We see that 1, 4 is not on the coordinate points right here, right? So we need to use the formula right here. Now we're gonna take sine inverse both sides, right? So it turns out to be s equals sine inverse of 1 over 4 plus k 2 pi. And the second one, s equals pi minus sine inverse of 1 over 4 plus k 2 pi, right? So these are two solutions to the given equation, right? Now let's look at example number 11. Find all solutions to the equation cosine theta equals -1/2, right? So we look at the unit circle. We need to find the x-coordinate that equals -1/2, right? So it's gonna be right here, this guy right here, and this guy right here, right? So the angle must be 2 pi over 3 and 4 pi over 3, right? So you have theta equals 2 pi over 3 plus k 2 pi, right? Because the period of the cosine function is going to be 2 pi, right? Or theta equals 4 pi over 3 plus k 2 pi, right? Now, the second way to do this one is you use the formula right here. Alright, so you have theta equals plus and minus 2 pi over 3 plus k 2 pi, right? 4 pi over 3, technically negative 2 pi over 3 if you go clockwise, right? Negative pi over 3 right here and negative 2 pi over 3 right here. Alright, so this formula right here can be written as S equals plus and minus cosine inverse of m plus k 2 pi. So I just basically use this formula right here, right? Now let's take a look at example number 12. Find all solutions to the equation tangent of pi over 5 minus s equal to, right? Now you look at this value right here, this is 2. When it comes sine or cosine function, this equation has no solution, right? Because it's outside the range, right? But when it comes to the tangent function, the range should be all real numbers, right? So this one works, right? Now first we need to find the domain for this one, right? We know that the domain s not equals pi over 2 plus k pi, right? So s in this situation is going to be the whole thing right here, right? So you have domain pi over 5 minus s not equal to pi over 2 plus k pi, right? So have negative s not equals pi over 2 subtract pi over 5. It's going to be 3 pi over 10 plus k pi, right? Now I just multiply both sides by -1, so s not equal to negative 3 pi over 10 minus k pi, right? Now I just rewrite this equation over here. I take tangent inverse both sides, right? So I have pi over 5 minus s equals plus k pi, right? So s equals pi over 5 minus tangent inverse of 2 minus k pi, right? Where k is an integer. Now let's move on to example number 13. This question comes from the AP Precalculus 2024. The function m is given by m of x equals cosine inverse of tangent of 2x. Find all values in the domain of m that yields an output value of 0. Alright, so we need to let m of s equal to 0, right? Because it says the output value equals 0, right? So it's the same thing as cosine inverse of tangent of 2s equals 0, right? Now you need to take cosine both sides so that you eliminate cosine inverse right here, right? So cosine right here and cosine right here. So this guy and this guy gone, right? So you have tangent of 2s equals cosine 0, right? Cosine 0 equals 1, right? So you have tangent 2s equals 1, right? Because tangent of theta equals y divided by s, right? So it can be root 2 over 2 divided by root 2 over 2. It can be 1. So the angle must be pi over 4, right? So I have tangent of 2s equals tangent of pi over 4, right? Now I use the formula right here. So I have 2s equals pi over 4 plus k pi, right? So then I divide both sides by 2. It's gonna be s equals pi over 8 plus k pi over 2. K is any integer, right? Now let's look at the next example, example number 14. Find all solution of 2 sine square of s minus sine s minus 1 equals 0 in the interval 0 to 2 pi, right? So I just rewrite this one a little bit. So I have 2 sine of s all together square, right? This guy and this guy same thing. Minus sine s minus 1 equals 0, right? Now I need to change the variable. So I let m equals sine s, right? And then you know that the range of sine should be negative 1 to 1. So m must be in the interval negative 1 to 1, right? So now I convert this one into variable m. So 2m squared minus m minus 1 equals 0, right? Now I need to factor this one out. So I use S method. A equals 2. B equals negative 1. C equals negative 1, right? Now I put A times C right here. It's gonna be negative 2. And B right here equals negative 1. Now I need to do mental math. I need to find two integers. Multiply equals negative 2 add up to negative 1. It's gonna be negative 2 and 1, right? So I have m minus 2 times m plus 1, right? Equals 0. I just put these two numbers right here. Now keep in mind, it's not the final factor form, right? Because you have a equals 2 different from 1. So you need to divide the constant right here by 2. Divide this guy by 2. So you simplify, so it's going to be m minus 1 times. Now this one right here, you can't simplify, right? So you either multiply 2 by m, or you just leave it, right? So I just leave it, m plus 1 half equals 0. This is the final factor form, right? Now I need to solve for m, right? So I have either m minus 1 equals 0, or m plus 1 half equals 0, right? Now I need to solve this one over here. So I have m equals 1, or m equals negative 1 half, right? Now I check to see if these two guys right here in the range right here, yes, right? 1 and negative 1 half inside the interval negative 1 and 1, so it's good, right? Now I need to substitute sine s for m, right? So I have sine s equals 1 and sine s equals negative 1 half, right? Now in the interval 0 to 2 pi, sine x equals 1 when x equals pi over 2, right? And sine x equals negative 1 half when x equals 7 pi over 6, right? And 11 pi over 6 right here, right? So you have the first one right here s equals pi over 2, right? Keep in mind you don't need to add a 2 pi, right? Because you given the restricted domain right here. This one right here only apply for the general solution, right? Now the second one right here you have two values s equals 7 pi over 6 and 11 pi over 6. Alright, so finally we have solution and it's good time to solve. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young.